Today, we are pulling back the curtain on the internet's secret language. This is the invisible set of rules that makes literally everything you do online work, from your video calls to that late-night shopping. So let's dive right in. Seriously, have you ever stopped to think about it? You click on something and bam, a website from the other side of the planet just appears. It feels like straight up magic, right? But it's not. It's actually this incredible, perfectly timed dance, all thanks to a very specific set of rules. And that rulebook, that's what we call the TCP IP model. Fun fact, it actually started out with the US Department of Defense. But the key thing to remember is, this isn't some dusty old theory. Nope, this is the real deal, practical framework that every single thing connected to the internet uses to talk to each other. Okay, so you might have heard of something called the OSI model. It has 7 layers, and it's a great blueprint, really useful for learning. But TCP IP is what's actually running the show. It's the one doing the work. It's way more streamlined, squishing those 7 layers down to 4 super practical ones. Why? Because it was built from the ground up to just get the job done, period. So that whole incredible journey, from your mouse click to a server and all the way back, it all happens across these 4 layers. We're going to follow one little piece of data as it makes this trip. Think of it like a road trip. We'll watch it go down the stack, out into the wild internet, and then come home. So let's start where it all begins, right at the top. Okay, step 1, the application request. This is the layer you actually know and use every single day. It's your web browser, your email app, your favorite game. It's where you interact with the internet. So think of it this way. When you type in a website, you're basically creating data. The application layer? That's you, writing a letter. You're putting down the actual message, like, "Hey server, I'd like to see your homepage, please." And this layer uses a bunch of different languages, or protocols, to get things done. You've probably seen these letters before. HTTP, that's for browsing the web. SMTP, that's for sending email. And DNS, that's like the internet's phone book. It turns a name you can read, like google.com, into an address a computer can understand. Pretty cool, right? Every job has its own special language. All right, so our letter is written. Now what? We can't just send it as is. We've got to package it up and make sure it gets there safely. And that brings us to step 2, the transport layer. This layer is kind of like the post office manager. It takes that big message you wrote and chops it up into smaller, manageable chunks. The whole point is to make sure every single one of those chunks arrives and that they arrive in the right order. It's the difference between a postcard and a registered trackable package. You want that confirmation. And here's where it gets interesting. This layer gives us 2 main ways to send things. First, you've got TCP. Think of this as the super reliable option. It checks for errors, makes sure every piece is perfect. It's what you use for a web page or an email where every bit counts. But then you've got UDP. UDP is all about speed. It's fast, it's simple, and it doesn't sweat the small stuff. Perfect for video streaming or online gaming, where a dropped frame here and there is no big deal. Speed is what matters. This choice between reliability and speed is what makes the internet so incredibly flexible. Okay, our data is all chopped up and packaged, but where's it going? How does it find its way across the globe? Well, that's where step 3, the internet layer, comes in. This layer is the addressing department. It takes those little packages from the last step and puts them into a digital envelope. We call this a packet. And on that envelope, it stamps the to and from addresses, the IP addresses. This is the global address that allows your data to travel literally anywhere on the internet. So yeah, this layer is the master logistician. It's in charge of those IP addresses, the unique ID for every device out there, and it uses routers. Think of them as the traffic cops of the internet. They're constantly looking at the traffic and deciding, okay, what's the absolute fastest, best path for this little packet to take right now? So let's recap. We have a message, it's packaged, it's addressed, it knows where to go. Just one more thing has to happen before it can actually leave your device. It has to stop being digital and become physical. And that's the job of our final layer on the way out, the network interface layer. This is where the digital world literally touches the physical world. It takes our packet of ones and zeros and translates it into something real. Electrical signals for your Ethernet cable, radio waves for your Wi-Fi, or little flashes of light for fiber optics. Our letter is now officially on the mail truck and on its way. Yeah, this is the real down and dirty hardware level. We're talking about Ethernet, Wi-Fi, this stuff that actually sends the signal. It also uses something called a MAC address.
Now, if the IP address is like your house address for the whole world, the MAC address is like your name on the mailbox. It's what makes sure the data gets to your specific computer on your local Wi-Fi network and not your roommate's.
And just like that, our packet is off. It's crossed oceans, been guided by all those routers, all as a physical signal. So what happens when it finally gets to where it's going? What happens at the server?
Well, you guessed it. The whole thing happens all over again, but completely in reverse. The server's network interface layer catches the signal and turns it back into a digital packet. The internet layer looks at the address and says, "Yep, this one's for me." The transport layer grabs all the little packets, puts them back together in the right order, and makes sure nothing's missing. And finally, the application layer gets the perfectly reassembled message and hands it off to the website software.
Boom. The request is received and understood. Now the server gets to work, grabs the web page you wanted, and sends it on the exact same 4-layer journey, just heading back to you. And the truly mind-blowing part? This entire round trip happens in the blink of an eye. We're talking milliseconds.
So there you have it. From top to bottom and all the way back again, the TCP IP model is this beautiful system where each layer does its own specific job and trusts the other layers to do theirs. It's a whole system built on trust, which leaves us with a pretty big question, doesn't it? In our world of constant cyber threats, what happens when that trust gets broken?